Now let's discuss about compounding. And then after that, we will also discuss about the opposite of that, which is discounting. And I will now correlate compounding with the future value and of course, discounting the present value, how we calculate that. We start with compounding, and it's really very important. It's the process of leaving your money in the financial market and then lending for another year or so. This is actually the total that you will receive, or the borrower should pay 2 years or 3 years from now by compounding the loan. In other words, the capital market enables the investor by providing a ready opportunity for lending to transform your $1 today into, for example, 1.1881 something, no, at the end of 2 years. So it's basically looking into the future today. Let me just start by sharing my screen. All right. Let's start with some terms. As I've said, compounding, it involves the calculation of interest periodically over the life of the loan or the investment, okay? So suppose you were to make a loan of $1 at 9% yearly interest, and you decide to compound the loan for another year, okay? Your borrower will owe you this computation, which is $1, and you want to compound it. If you compound it for 1 year, you multiply it with 1 plus the rate. If you want to compound it for another year, you multiply it again with 1 plus the rate. Or in algebraic terms, it's $1 plus 2r plus r raised to 2. Okay, this equation here. What if you compound it for 3 years? Then it's 1 plus 3r plus the rate raised to 3. What about for 4 years? 1 plus 4r plus r raised to 4. Okay, so that's really very simple when you compound something. You're putting your interest on the interest. You're compounding your interest periodically, depending on the number of periods over the life of the loan. Let me expound further. Okay. By looking into the difference between the simple and the compounded interest. So when the cash is invested rather at compound interest, each interest payment is reinvested. Okay, so that's your compound interest, right? So you reinvest your interest payment. So again, it's like you have an interest on your interest, okay? But this is not the case with simple interest, all right? Well, I just put here a table. The $1 is our base, okay? And then you have here on the second year, the third year, and the fourth year, so not just like compounded for 4 years, okay? The second year, you have 1.09. And then on the third year, the blue region is your simple interest, okay? It's 1.180. But look at your compound interest. It's 1.188, okay? You compound it, you reinvest it. On the third year, the blue region is 1.1270. So it means that you came from 109, you go to 1.180, you go to 1.1270. That's simple interest, right? But when you compound it, you start from $1, then you go 1.09, then you compound it to 1.188, you compound it further to 1.1295. See, there's a substantial difference of the simple and the compounded interest over many years or decades. Can you imagine if you compute the difference between 1.180 and the 1.188 and the difference between 1.270 versus 1.297, and you think of many years, 5 years, 10 years, decades, right? So money makes money. And the money that money makes more money, right? So money makes money. What is that? It's the interest, right? And the money that money makes, the money now is the interest. The interest over that interest makes more interest, okay? And that's the future value of an investment. The future value of an investment is computed as FV, which is equivalent to your cash to be invested at whatever date, multiplied by we call that the future value of $1, which is 1 plus R raised to T, or the number of periods. Let me expound further, okay, by looking into this example. So Su Peng Ku has put $500 in a savings account at the First National Bank of Kent. The account earns 7% compounded annually. How much will Miss Ku have at the end of 3 years? All right. So if this is the case, we're looking for the future value. And I said the future value is equal to the present value times, we call this the future value rate, or 1 plus R raised to T, okay? So what's our present value? Our present value is 500. It's the initial amount that was placed in the savings account by Miss Ku. And then 1 plus what's our rate? It's 7%. And it's compounded annually. So we want to know what it will be the future value at the end of 3 years, okay? So 500 times 1.07 raised to 3, okay? So when you calculate that, well, in your calculator, you can use a scientific calculator. So you start with the exponent, right? The PEMDAS. So it's 1.07 raised to 3 is 1.2250. Multiply it with 500. Okay. And the answer is 612.52. Okay. So that's 612.52. You can compute that again if you want, but that's how you calculate your future value. Okay. Now let's go to the next one, which is, well, this is something that you can also do. You can put that in the spreadsheets. So in Excel, you go to financials, formulas, and then this is, you choose FV, okay? So here you will see the PV is 500, the rate is 7%, and the time is 3 years. You just put all the values there, and you will see the same answer, which is 612.52. You can try it on your own. Okay, now these are the future value of $1 at the end of T periods. It's really very easy how you compute this. It's just like, for example, let's take, for example, this one. No, I said this is the one with the box. So how do you get this? All right. So it's basically 1 plus R raised to T. Okay. So it's 1.07. And how many periods? We have 3, right? Therefore, it's 1.2250. Okay, so in this example, if your initial investment is 500 pesos, you multiply it with the future value of $1, which is 1.2250, then it's equivalent to 612.50, just as what we have in our example. Now let's have this another example. J. Ritter invested 1,000 in the stock of the SDH company. The company pays a current dividend of $2, which is expected to grow by 20% per year for the next 2 years. What will be the dividend of SDH after 2 years? Okay, so again, we're talking about after 2 years. So you want to look for the future value. Okay, so FV is equal to PV times 1 plus R raised to T. Okay, and then your PV is, we want to know the dividend, right? just the dividend. We don't want to know about the returns. So you focus on the given, which is the dividend also. That's your future, that's your present value. So that's $2 times 1 plus R, 1 plus your rate of 20% or 0.2. And we want to know after 2 years, right? They said, yeah, there's nothing to compound. It's just plainly 2 years. So the answer here is 1 plus. So you start first with a 1.2%. Sorry, 1 plus the 20% is 1.2 raised to 2. Okay, equals 1.44 times 2. That's 2.88. 2.88. Okay, so it means that the dividend after 2 years will be 2.88. You're right. Okay, so just a few more explanations about the power of compounding. So a few years ago, an archaeologist unearthed a relic stating that Julius Caesar lent the Roman equivalent of 1 penny to someone. Now, because there was no record of the penny ever being repaid, the archaeologist wondered what the interest in the principle would be if a descendant of Caesar tried to collect from a descendant of the borrower in the 20th century. Okay, so that is from Julius Caesar time to the 20th century. Okay, now the archaeologist felt that a rate of 6% would be appropriate. To his surprise, the principal and interest due after more than 2,000 years was vastly greater than the entire wealth on earth. See, just coming from a penny, it is now equivalent, the future value, the value now is equivalent to the entire wealth on earth, or rather the present value now, okay, when you try to discount it. Now, the power of compounding can explain why the parents of well-to-do families frequently bequeath wealth to their grandchildren rather than to their children. That is, they skip a generation. And it's something, I don't know where this is happening, but well, what we know today is that parents are more likely to be, very attached to their grandchildren more than their children. But in finance, it's more to that. There's more to that because compounding can also be applied to them because they skip a generation. The parents would rather make the grandchildren very rich than make the children moderately rich. We have found that in these families. The grandchildren have a more positive view of the power of compounding than do their children because, well, they have more money and they saw the benefit of their grandparents bequeathing the wealth to them rather than their parents, right? So that's the power of compounding. It's really funny and interesting facts about compounding. Now, let's go to the other side of the spectrum, which is the present value and discounting. Okay, now discounting, it's the process of calculating the present value of future cash flow, right? It's like you're given you are in the future. You want to go back to the past. You call it discounting. So the present value of $1 is equal to a future value of about 1.1881, the rate of about 9%. The term or the period is 2 years from now. Okay. How much would an investor need to lend today so that she would receive $1 2 years from today? 2 years from today. Okay. So we're talking about today. So you want to know the present value. And this is how we will compute that. Okay. So the PV is equal to your cash flow, or we can say, I would say the FV or the future value, because what will be given to you is the future value. Okay. And then you multiply it with, 1 over 1 plus R. Okay. 1 plus r raised to t. But in reality, when you compute it using algebra, it's basically fv over 1 plus r raised to t. All right. So if your future value is $1 and your 1 plus r raised to t is 1.09 raised to 2 years. How much is that? 1.09 raised to 2. So that's it. So you can actually, when you calculate it in your, when you use your scientific calculator, you say 1 divided by 1.09 raised to 2 equals, I don't know if I got it right, but it's says here 0.8417. Yeah, I think so. I think you got it right. Okay. So it's 0.84 something. Okay. So it means that a $1 in 2 years from today, okay, an investor should lend 84 cents so that she would receive $1 2 years after or 2 years from today. Okay. So that's discounting. So if compounding, you will get a higher number from your cash flow or from your present value. You will get a higher number, because you're talking about the future, right? You're compounding. Discounting, it's the opposite. You get a lower number because you start from the future and you're going back. Okay. Yeah. So we call that the present value factor. Okay, so main difference of compounding versus discounting. Okay, just read through this, and you will see the graph, which is basically the top line is your compound interest. At our example of $1,000 with the funds invested at 9%. Okay, compounding at 9%. So it's in the higher spectrum of the graph, and when you discount it, you go back into the past, right? The discounted value is your present value. When you're computing for the present value, that's how you discount it, which is equal to your cash flow divided by your future value rate. Okay, we'll have more examples of this as we go along. All right. The other formula that I want to leave to you guys is the effective rate. We also call it the APY, or the annual percentage yield. It's just your interest for 1 year divided by the principal. You basically calculate first either the future value or the present value. Okay, and then you compute for the APY, or interest for 1 year divided by the principal. But remember the basic formulas, okay? For compounding, we're talking about the future value. And the future value is equal to your present value times your future value rate. Your future value rate is 1 plus r raised to t. Okay, and when you discount, you're actually looking for the present value. And the present value is equal to fv times 1 over 1 plus r raised to t. Or make it simple, okay? fv over 1 plus r raised to t. I don't know where there's always an underline, but yeah. Okay, now let's look at these exercises. Compute for the present value with the following givens. It's something that will be easy for us to start, but as you go along, it will be a lot easier, actually. Now, the future value desired is $7,000. Your time is 6 years, and you compound it for, well, semi-annually. So it's always 6 times 2. Okay, that's why it's 12, because it's semi-annual compounded. And then your rate is actually 6% divided by 2. So yeah, it's already here. So that's 3%. Okay. So we're asked to compute for the PV, and we know that our PV is FV divided by 1 plus R raised to T. Okay. Our FV is 7,000, and our present value factor is 1.03. Okay. This one. 1.03 raised to 12. Okay, therefore your answer is, so again, it's easy. You just put in the calculator, 7,000 divided by 1.03 raised to XY 12. Well, I got 4,909. Yeah, okay. So let's remove that for a while and then just savor my glory. 4,909.7 something. Okay, it means that I have to invest 4,909.7 for me to gain after 6 years, $7,000 compounded semi-annually with a rate of 6%. All right.